Hello everyone. So today we got a great topic about inheritance. Inheritance is the fundamental idea behind object-oriented languages. In fact, it is implied by most mathematical structures also. This probably explains why the object-oriented paradigm is so robust for software engineering. Object-oriented languages, like Java, allow us to extend a class when we want to reuse existing behavior while adding or refining functionality. We identify is-a type relationships. For example, a student is a type of person. All the traits of a person apply to a student, such as the birth date or government identification number, but students may have traits that are not applicable to every person, such as their student ID. Extending classes helps reduce duplicated code and makes managing programs easier. Extending classes also allows developers to use polymorphism techniques. So imagine a polymorphism is like calculating the area of a two-dimensional polygon. All two-dimensional polygons have an area, but that specific area calculation will differ based on the shape. To extend a class in Java, we use the extends keyword. The subclass automatically inherits all public and protected members of its parent class. Java only allows a class to extend one direct superclass, which keeps the inheritance structure simple and avoids ambiguity. Other object-oriented languages, such as C++, allow a class to extend multiple classes. This can lead to situations called the diamond problem, but that'll be out of scope for this lecture. When a subclass object is created, which is what the extends keyword does for us, the constructor of the parent class will always execute first. If no constructor call is written, Java automatically inserts a call to super with no parameters. However, if the parent class requires constructor arguments and it does not have a default constructor with no parameters, the subclass must explicitly call super with the appropriate parameters as the first line of its own constructor. A subclass can override methods from its parent class to provide specialized behavior. To override a method, the method name and parameter list must match exactly. The return type must be compatible, and visibility cannot be reduced. Using the @override annotation helps catch errors at compile time and makes the intent clear. Sometimes we want to extend behavior rather than completely replacing it. In these cases, the super keyword allows us to call the parent class's version of a method. This is commonly used inside the overridden methods to reuse logic defined in the superclass while adding additional behavior. Access modifiers play a critical role in inheritance. Private members are not accessible in subclasses at all. Protected members are accessible within subclasses, even across packages. Public members are always accessible and are fully inherited. The final keyword is used to prevent inheritance-related changes. A final method cannot be overridden, which guarantees consistent behavior. A final class cannot be extended at all. These restrictions are often used to enforce design decisions or protect critical logic. Sometimes classes are never meant to be initialized directly. In this case, they are meant to simply serve as an encapsulation tool. For example, we could have a class called vehicle. No one ever buys just a vehicle, but rather a specific brand of a vehicle such as BMW. In this case, a class called vehicle may be declared as abstract. This would mean the vehicle class would solely be used to encapsulate data common to all vehicles, such as the VIN number. Other classes representing the actual makes and models may extend the vehicle class. At this point, I would like to go to my computer and walk through several examples that demonstrate class extension, constructor chaining, and method overriding. These examples will help solidify how inheritance works in real Java programs. So I guess I'm going to start with, let's create a new package, just so we can kind of keep everything kind of together. And let's create a package called 2dim shapes, okay? 2dim shapes. Now, when we talk about two-dimensional shapes, we kind of need to be mindful of something because we could have a rectangle and a square or a triangle, and all those are kind of like a bunch of points with lines connected together that enclose an area. And then we have something like a circle and various other versions of that to where you kind of have curved edges, right? So we have these polygons and then we have these non-polygon two-dimensional shapes. So there's going to be something kind of related in that they both have a perimeter. In the circle, we call it the circumference, but we're going to refer to it as the perimeter anyway. We're going to have these polygons and we're going to have these non-polygon rounded edge shapes, but they both categories will have an area and they will have a perimeter. So that will be common to both of them. They can be calculated different ways, and it really depends on what the shape is. Okay, so what I'm going to do is I'm going to create two other packages. I'm going to create a package where I'm going to refer to as polygons, and then I'm going to create another package where I'm going to refer to this as non-polygon. Now, when we're talking about a polygon, what kind of polygons maybe are the classic ones? You may say rectangle, square, and all that, so we're just going to do a few. Actually, maybe just one or two. Let's go ahead and create a Java class, and we'll refer to it as an enum, because we want to maybe have a category for these. So shape types or shape category. Okay, now in this shape category, in our two-dimensional shapes and in our polygons, we're going to have this enum, and I guess we're going to have something that we may refer to as a rectangle. Okay, and then let's create something, maybe a triangle. Okay, so just to give us something, right? Now you may be asking, why don't you put a square in there? Well, I'm going to show you because I'm actually going to play on that, because a square is a special case of a rectangle. Remember, a rectangle has what? It has two sets of parallel sides of equal length. That definition holds true for a square, except all sides are equal length. So just bear with me, and I think I'll be able to just demonstrate where we're headed. So we're going to have a rectangle, and I'm going to say, let's have a place where we're going to store that string. So it would be private final string category name. Okay, then we'll create the constructor, shape category, string category name, and then basically we're just going to set that this category name is going to be equal to category name. Now if you look, I believe this thing's probably complaining that says, well, you set this but you're never using it. So let's go ahead and do this. We'll say public string get category name. Okay, and everything seems to be happy about that now. So I just got an enum, so that way I could just kind of label things what we got, because we don't want to say, oh, that's a rectangle, because not all four-sided things are going to be a rectangle. We want to be very specific about it. Okay, so now in our polygons, I think the next thing that maybe I should do is have like a class to where we're just going to call it a polygon. Now in this particular case, we don't want to allow our users to just create a polygon class, because why? Well, we need to be sure about which polygon we actually have. So we don't want people to actually be able to create an instance of this. So I'll say this is an abstract class called polygon. Now, what's important about a polygon? Well, let's go ahead and say maybe we're going to have private final integer, and then we could say number of sides. That's important, right? Private final integer number of sides. Okay. Now, I guess our polygon, maybe we don't want to have any more information about that. Well, if our polygon, if we're going to have an enum, maybe we should have that there. So we're going to say private final shape category, and then we'll say shape category. Okay. Great. Now we're going to say public, now let's say polygon, create a constructor. So what would the constructor look like this? Well, we probably need to have the number of sides. So we'll say integer number of sides, and then we'll say let's pass the enum in as well. Okay, great. And then in this constructor, we'll basically say this number of sides is going to be equal to number of sides. This shape category is going to be equal to the shape category of the parameter. Great. And as usual, this thing is saying, well, you set this, but you're not using it. So I guess we need to have getters for this. So we'll say public integer get number of sides, return this number of sides. Great. And then we'll do this public shape category get shape category. Okay, so now we basically have an abstract class. Now, what this means is that no one can create an instance of this class. So just to demonstrate that, let's suppose that I'm going to do my best to give that a shot. This is going to fail, but let's give it a shot. We're going to say polygon. Okay. And we're going to say new polygon 1 is going to be equal to new polygon, and then what I'm going to do is I'm going to put in here number of sides. What is that? Well, see, IntelliJ helped me. So I'm going to say let's do 4, and then we're going to put in shape category dot rectangle. Okay, and we have an error, and let's go look and see what this error is. It says polygon is abstract, cannot have an instance of it. Okay, now if I wanted to, I could click this and IntelliJ would fix this problem for me, but IntelliJ doesn't know what I'm wanting to do here. So that's okay. So basically we know that this is not possible because polygon is abstract. We can't create an instance of it. Okay, so now we're going to have to go to our code. And since we got a polygon, let's go ahead and create another class to where we're going to say another package maybe, and we're going to say shapes or category. Actually, you know what? Let's rename that. Since our enum is categories, let's put categories. Now inside of here, we know immediately that we're trying to do a rectangle. So let's go ahead and create a Java class and let's call it a rectangle. Okay. So we call it a rectangle. Now, on this rectangle, we're going to basically have the length and the width. That's going to be important. So we're going to do private final double length, private final double width. Okay, so those are going to be the two parameters that we're going to know about, because that's all you have to define a rectangle, right? So let's go ahead and let's define this to be the constructor. We're going to say public rectangle, and we're going to pass in the double length and the double width. And all the constructor is going to do is basically set these values. So it's going to be this dot length is equal to the parameter that we're passing in. This dot width is going to be equal to the parameter that we're setting in. Notice that IntelliJ helps you. Whenever you have this, notice that it's highlighting this to show this is the variable up here. When you click this, notice it's showing the parameter. It does it for width too. You see the difference? Okay, great. All right, so that's the constructor. Well, it says you've used the length and you used the width, so you set them, but you're not using them. So I guess we should probably maybe have a getter. So we're going to say public double get length, return this dot length. Great. Public double get width. Okay. So at least it's satisfied. Now we got a yellow line. It's always important to look at the yellow lines whenever you're looking at things. So you look, it's going to say class rectangles never used. That's okay because we'll get there. All right, so we're going to have main. And I guess since we have a rectangle, isn't a rectangle a polygon? And so what does a polygon, our rectangle class, what does our polygon class ask for? The number of sides in the shape category. And since our rectangle, everybody say it with me, is a polygon, since a rectangle is a polygon, then we should expect rectangle should extend polygon. All right. Now, we have this now. So when I type that in, notice that IntelliJ says import this in so we can use it because we're in multiple things here. And immediately when I did this, notice that, so let's be clear, what does the extends do? We're now saying that rectangle is a subclass of polygon. So basically rectangle extends the polygon class. Every rectangle is a polygon, so we're good. Now notice that the constructor here is now going to complain about this. It says there is no R constructor available in polygons. So what that's basically saying is it's saying that, you know, you're doing this, But since now that rectangle extends polygon, you're going to have to actually call the polygon constructor so that way we can kind of walk up the chain. Okay, well, I'm going to show you, this is going to be wrong, but I'm going to show you something. The way that we call so since rectangle, and by the way, you can only extend one class in Java. That's not the case in C++. You could extend multiple classes. One class can extend multiple classes in C++. In Java, one class can only extend another class. A class can only extend one class. Now, so that means I'm going to have to use the word super. What super means is I'm going to call the constructor of the class that I'm extending. So remember, since I'm in a polygon, since I'm in a rectangle, I definitely know that the number of sides is going to be a 4, right? And since I'm definitely in the shape category, I can go ahead and define myself to be what? A shape rectangle. Okay, now it's already complaining about something else. I'm going to tell you that in order to make this work, the super call has to be the very first line in the constructor. So when I hover, it says call to super must be the first statement in the constructor body. That's okay. So I believe when we do this, this should be okay. Just copy it, just cut it and paste it there, and now you see that we got it. Okay. Now, we have get length and get width. Let's go back to polygon. What are the getters for this? We have something that will return the number of sides, and we have something that will return the shape category. Notice that my rectangle does not have those things. It just says get length and get width. That only applies for a rectangle. Whenever you say get the length and get the width of a triangle, you have to be a little bit more careful because why? The length and the width are kind of maybe not actually sides of the triangle. So maybe you want to have get side A, get side B, get side C. Great. Okay, so now let's go over to main and let's see if this will work. So I'm going to say rectangle, and I'm going to say rectangle 1, new rectangle. And inside of here, all I have to do is put in a length and a width. So I'm going to put length 4, length 6, and we've got it. Now I can do system.out.println, and I could say r1 dot get length. Now to get this, so it's saying get length and get width are both available, and that makes perfect sense. Why? Because we have a get length and we have a get width. Our problem is, well, it's not a problem, it's actually functional, right? When I do this, notice that it's also allowing me to choose get number of sides, get shape category. That is not in rectangle. So where's that coming from? Oh, it's coming from the fact that since rectangle extends polygon, rectangle is a polygon. So, and since the constructor of polygon requires number of sides and shape category, whenever I'm calling my constructor for the length and the width for my rectangle, I'm actually calling super where I'm manually setting 4 and the shape rectangle. Since I'm in rectangle, I know it's going to be the case, and I set these two. So that means every one of these public values for polygon is going to be available to rectangle because a rectangle is a polygon. So let's go ahead and just ask what these values are. So get length, make this a little bit easier on myself. Okay, in this case, we'll say get number of sides, get shape category. Now that's getting the shape category. Now we want to do dot get category name. So I guess to help this out, we'll do length, okay, then we'll put number of sides, and then category name. Okay, and then when we hit run, hopefully this works. Took a bit, but we got it. So what do we say? Our rectangle was 4 and 6. So we have length 4, length 6, number of sides 4, and the category name is rectangle. So it seems like everything's working, right? Now, one of the cool things that you might be able to mention about this is I would like for everybody to be very aware of this. Even though Polygon is an abstract class, you can still use Polygon to type something. So watch what I'm going to do here. I'm going to say Polygon is the type, and I'm going to say RR1 equals new rectangle, and I'm going to pass in the values 5 and 6. Okay? Now, the only problem with typing it as a polygon is whenever you come down here and actually ask these values, we might have a little bit of an issue. So let's see what happens. So we've defined this to be polygon RR1, new rectangle this. Let's see what happens. Okay, so you have rectangle 5, rectangle 6. Okay, so I've experienced something here that's kind of catching me off guard. This shouldn't run because I've declared polygon. Oh, I see. Sorry. RR1. Okay. My bad. Copy paste here. My bad. Now, notice that it's complaining about this because whenever we set the top for this, we're declaring it a polygon. What's the only thing a polygon has available? It only has available get number of sides, get shape category. So what we could do is we could use polygon to declare anything that is a polygon if we wanted to, except it will not have the specifics associated with that class that's extending it. You only have these things, which is part of the abstract. So we're going to say will not work because not part of polygon. Okay, same thing down here too. All right, so will not work because it's not part of polygon. All right, so just to be clear, whenever I did it earlier, I copied and pasted this, so I was actually printing out R1 down here. That's the reason it worked. But then I declared, so look here, I'm calling polygon. I can use abstract classes to type something, but whenever I'm using the methods, I could only use the methods that are common to polygon and not the one specific to rectangle. So that's something to be very, very aware of. Okay. And it's handy because what if I wanted to create an array of polygons? Well, if I declare the array of polygons, I could put the triangles in there. I could put the rectangles in there. I could put the squares in there. All that would be fine, except I would only be able to get the number of sides and their category name. I wouldn't be able to get their specifics about their individual classes. So typing these in a general way is very helpful sometimes. Other times it can be a little bit of a headache. All right, so now we got a rectangle. Well, we all know something very specific about a rectangle is that we also have something that may be called a square, right? So we're going to say a square. But a square is just a special case of a rectangle. So we say a square is a rectangle. So we'll say square extends rectangle. Okay, so now when we do this, we don't actually need all the information about a square, right? We only need one side length. So we're going to say private final double side length. Okay. Now in the constructor, we're going to say square, and we just have to pass in the side length. Okay. Now we say this side length equals side length. Great. That takes care of that. We probably want to have a getter that says public double get side length. Okay, now the problem is what is this saying? If you're going to extend rectangle, rectangle has a constructor that requires 2 parameters. That's fine. So if you are a square, then you are certainly a rectangle. So we need to call super, and we could put in here the length. Well, it turns out that this is just going to be what? The side length, comma, the side length. Now notice what I don't have to put in here. I don't have to put in here what? uh, the shape category, because all squares are rectangles, and so when we call the super, it's going to automatically set itself to the rectangle and pass that on up to the constructor. So as you can see, we're kind of building on these things. What it is basically you start out with the most general thing, and then as you progress through extending classes, you become more and more focused with a little bit more specifics. But everything that's in that chain has to be is a relationship to the thing it's extending. Like a rectangle is a polygon. A square is a rectangle, right? Okay. Now we go over here to Java. Notice what we're going to be able to do now. We could actually say square, and we could say S1 and new square. And in this case, all we have to do is pass in like a 4. Oops, I don't know. Good. And then for S1, notice all the things that we could do. We could get the length, the width, the number of sides. All that's going to be defined. So we just have to make sure I don't do that mistake again. Okay, and then not only that, we're going to be able to say system.out.println, and we could say side length there we go. And notice that when we print this, oh, I forgot to comment these out because those won't compile. So when I hit play, notice that it's working again. Now we have the square, and we have the length 4, the width 4, number of sides 4, side length 4, and then the category name is a rectangle. All right, so everything seems to be working out just fine. Now we got to go in here and we actually got to say polygon. Well, every polygon, what do we say? Every polygon is going to have some method that's going to say get area. So I guess what I want to do is that anything that extends polygon, I should require it to say, I have a method that says get area. But I can't really have it calculate the area because that's very specific on the actual shape. So what I can do is I could call something an abstract method, and I could say abstract method double get area. Now, what does this mean? This means that, well, we can also have another one. Let's say abstract double get perimeter. I'm very struggling to type today. So whenever you declare something abstract as a method, now whenever you declare something abstract as a class, it means that it's kind of an encapsulation container and that things are meant to extend it. Whenever you declare a method abstract, that means that you're going to require everything down the chain to provide get area and get perimeter, but there's no way for you to actually define how that's going to be done here. All right, so let's go to rectangle. And notice that there's a problem now. The problem is that class rectangle must either be declared abstract or implement abstract method get area. Why is it complaining? It didn't complain before. It's complaining because when I went to polygon, I declared a method abstract. When a method is abstract, it means that the class extending it has to declare it. The Polygon class itself cannot calculate get area because it has no idea how to do that because it doesn't know which specific shape that it will be that this will be applied to. And the same way with perimeter. But what we can do is we could require rectangle to do this. So we're going to do this public double, and we're going to say get area. Now how do we know what the area of a rectangle is? This is very simple, so we're just going to return what? This dot length times this dot width. Okay, and that should be it. That should be good, right? Now this thing is complaining again. Why is it complaining? Well, we also have abstract. Wait a minute, did I screw up here? Public get area there. Okay, so we're going to investigate why this is. So if we don't mind, let's go ahead and just comment out this. Well, we'll leave it. Rectangle, so it says get area. So why does it say this has to be protected? Abstract area. Well, we are going to have to make this available to everybody. So if we're going to have a double get area, let's see what this is asking for. Let's see if IntelliJ can help us with this. Okay, now what do we got? It says we also have to have a get parameter. So we're going to go over here and we're going to say public double get parameter. And what is the parameter? We're going to return this 2 times this dot length plus 2 times this dot width. Okay, so we got it. Now what's this thing complaining about? It says make polygon get protected. All right, so where did all this take place at? So we go up here to polygon. It says protected. So let's be clear, whenever I declare this abstract, what does protected have to mean? It means that whenever protected is involved, you're going to be basically sharing it with everything in the subclasses. So if I wanted to, the reason that this is not working right now is because even though I'm requiring that to be there, it's not public. So I guess we could say make this public. What did IntelliJ want to do? IntelliJ was basically telling me protected is a little bit safer if it doesn't know what's going on, so it'll always kind of go with the least privilege. It was saying protected. We actually want to make it public. So we're going to have a public abstract double get area. So what this means is everything that extends polygon is going to have to make available get area. It has to, because that's what it means to be abstract. Polygon class itself can't define it, but it's going to require everything that can be an instance of it or extend it does have to make it. Now, if you were to declare the class extending it abstract, then that passes the buck on down to the next one. So whatever through that chain creates an instance, it's going to have to do all these abstract ones. All right, so sorry about that. I had a little bit of an issue whenever I was suggesting this. So we have now public get width, public get length, public get area, public get parameter, and everything is satisfied. Now, do we have to actually do that for the square? No, because the square is actually extending a rectangle, so that means that these methods that are in rectangle are automatically available, and we know that the calculation will work for the rectangle. It will also work for the square because a square is a rectangle, and this is basically demonstrating that. Okay, so we have a square. The square is basically done. Doesn't do anything else. The rectangle, we just had to make sure that it implements this get area, get perimeter. It doesn't have to be declared in the square because all the public methods of rectangle are available to square, so we get that for free. So now we go over here and we're going to ask, let's go ahead and get the area of these things. Notice that I can go up here now and I could actually request that. I could say system.out.println area. And why is that fine? Because this is actually defined in the polygon. So since it's just abstract, it's still public. So let's be clear. In polygon, notice that it is not defined on how to calculate area. That's actually inside a rectangle. But since it's public in polygon, polygon is requiring anything that extends it to use get area by the abstract. But that same method gets kind of passed down through to make it public for anybody asking for it. So that means polygon, even though this is declared polygon, it still has the area available because it's in that class. And we'll say parameter. Perfect. All right. Now notice that square will also have this available. System.out.println. We'll say area. Notice there it is. And system.out.println. Okay, and we hit play. Notice that's running. Notice that the area of our square is 16. Notice that the perimeter was also 16. Okay, good. And rectangle, what was our, for this one is 5 and 6, so that should be what, 30 as an area. And then 5 plus 5 is 10, plus 6 and 6 is 12, so it should be a perimeter 22. Good, so everything seems to be working. Now, the only thing that I didn't actually demonstrate right now, so we've got abstract classes, we've got a few of these other things. Let's go ahead and let's assume that we're going to make something in Polygon private. So we got number of sides. So we're going to say in rectangle, maybe we just want to do this for the sake of doing it, who knows. We're going to say public double get number sides. Okay, I want to make sure they're not overloading the previous one. So I'm going to return back this dot. Now, notice that I do have the ability to get number of sides, so I can actually call this thing polygon, but notice that I cannot access this directly, this number of sides. So this number of sides, it won't. It's only let me get the method involved with it. Now, I want you guys to see, when I do this, and I'm going to say get number of sides, it's only allowing these two things to happen, right? In this case, I'd be calling myself. In this case, I'm calling this inside of this. Now, watch what happens whenever I migrate this to protected. When I migrate this to protected, I can then go to rectangle, and I could say this number of sides. Okay, so that's defined in Polygon as protected. What does protected mean? That means it acts like a private variable for all these subclasses. Nothing outside of the subclasses can actually use this, but the subclasses have access to it. That's what it means to be protected. You can declare methods or variables. You can declare many things, protected, private, final, whatever, or private, public, protected. But let's be clear, this is okay because it's protected. Notice that the other variable, which is what, shape category, it is not, so I cannot do this. I cannot return that one. Now, watch what happens when I do this. I'm going to go over here and go polygon, and I'm going to change this back to private. And you notice that I got one related problem. By the way, if you click this in IntelliJ, it'll take you right there. Notice that this is no longer available. Why is that? Private variables only belong to the class itself. It has nothing to do with things being extended. Protected means that any subclass can have access to it, but the outside world, it appears like a private, like a private member. Now, inside of Polygon, if I put this back to public, if I put this back at public, and I don't like doing that with the variables because that becomes a little bit odd, or it becomes a little bit unsafe. But when we look at rectangle, notice that this now becomes okay because everybody would have access to it, including the outside world, but that's not a good idea. So we'll go back to private, and there's no real reason to get this because we already have a method to the outside world that says get number of sides, so we don't need that. Okay, so what we've done is we've described what it means to declare a class abstract. We've described how to use the extends mechanism. The only thing we haven't done is when we're talking about overloading. So just to be clear, since square is a rectangle, this area is completely fine. So what I'm going to do is I'm going to put a little print statement in here just so everybody can see what happens. Print ln, and I'm going to say this is from rectangle. Okay, so watch what happens when I go over here. Do you see where it says get, what was that, sorry, get area. This is from rectangle. You should see that print out there. Notice that you did. Right before it printed the area, it first printed that thing. This says this is from rectangle, and you'll see it up here too. Now, what I want to do is I want to go over here to square. So everybody's saying, you know what? Since square is kind of a simplified thing, we might be able to get away with computing it easier. So when I do public and I do double, I could do get area, and I could basically, what we could say, overload this or override this. So since we have a square and it's going to have a get area, that means that I could actually do this calculation. So I could do system.out.println, and I will do this is from square, okay, and then I will say return what is the, should be side length times side length. All right, now I want to go over here to main, and I'll print this. Notice that this one comes from rectangle. Notice that this is coming from square. So why is that? Whenever I called get area, we know where square is. And what it's going to do is it's going to traverse all the way up through that chain of subclasses, starting at square, and it's going to find get area. In the first instance where it finds something called get area, it will actually return that value. Now let's suppose that I want to actually call something. So do you see how I've got this get area overridden, right? I can actually still call the rectangle version by doing this. Instead of this, I could do this, and I could say, I'm sorry, I'm in the wrong place. I need to go to square. So in this case, I could still call rectangles, and watch what happens when I do this. I'm going to play a little trick here. I could say super.getArea and do that. Anytime I issue the super keyword, I don't know if that's going to work or not. Oh, sorry, return. There we go. So, yeah. So whenever I call get area, what you're going to see is it's going to say, I'm going to print out this is from square, but it's not going to return the actual value. Then what it's going to do is it's actually going to return what the value is going to get. Super means that it's going to call the method found in the super class, which is the rectangle. So rectangle is the super class relative to square. So when we say super get area, you're going to find that whenever I call get area in the square, it's going to say, hey, this is from square, but it's actually going to get the value from rectangle. So what we should see is it should print this is from rectangle right away, and then return this value. Then it will return this value here, and then it will return it back. So this is kind of a bad way of doing this, and this is kind of silly, but let's just watch what happens. Notice this. So when we did get area, let's walk through the flow. Whenever I did the square get area, it found get area here. It was the first place that it found it. As it's walking through that chain of subclasses from polygon to rectangle to square, square had get area defined, so it used it. It says this is from square, prints it out. But instead of returning a value, it's actually going to go up and ask, hey, rectangle, give me your value for area, since it should be the same thing. So then when it goes up here to rectangle, it prints out this is from rectangle, and then it returns this value right here back to the square, and so that value is right here, and then square returns it to give us this. So it says this is from square, this is from rectangle. Rectangle sends it back to the get area in the square, and then square get area sends it back to the main method. Now again, you would never want to do this, and in fact I would recommend that since rectangle would perfectly compute this, unless you had some shortcut in the computations that would really win you a lot of overhead, I recommend not doing this. So this basically means what? We've overridden get area so that now our square is doing it instead of rectangle. But we could always differentiate. So if I was to do this, you're going to see IntelliJ complain. Why would that complain? Well, when we run this, it's going to get caught in a loop because here it says get area in square, and it's basically going to keep iterating over and over. So if you look, it's going to say this is going to recurse infinitely, and it can only end by throwing an exception. So when we call get area now, this get area is actually calling this get area, and so you end up in kind of a circular problem here. But when we do this, super, that means call rectangles get area. So this is a way that you could have things overridden, but you could still get the other one, so to speak. Okay, great. So hopefully that made sense. Hopefully you guys enjoyed that. Hopefully you learned something kind of cool. And I'll go ahead and push this up to my repository so you guys can have it available if you want to see this test code. I'm going to remove this just so we don't look kind of silly about it. Make sure this works. Okay. Notice that that should go away. Now we're back from the rectangle, right? Okay. Now I'm going to push this code to my repository, and I'll share that repository with you guys so that way you can have it. Okay. So that wraps up the code demonstration. Let me take a moment to summarize all that was discussed and demonstrated. Inheritance is the fundamental key to the object-oriented paradigm. There are many object-oriented languages, such as Java, C++, and Python. The keyword extends is how we indicate to the Java compiler that a class should extend another class. Abstract classes are simply an encapsulation tool and cannot be extended. Classes marked final cannot be extended. Methods marked final cannot be overridden. Private members of a class cannot be inherited. All public members are inherited and fully accessible. Protected members are accessible to the subclasses. Super refers to members of the class being extended. When done properly, object-oriented frameworks are scalable and easier to maintain. So that basically wraps up this presentation. Thank you for taking the time to watch this lecture. I look forward to your feedback and questions as you continue working with inheritance in Java.